Students, we are starting today a lesson from Science 1. It is classification of elements. In previous standards, you have studied the metals, non-metals, and their some properties. And this year we are studying the classification of elements. Classification means metals or non-metal, that is different, but elements, how they behave and on their behavior or their reactions, they must be in the one group. They must be in the group, so that we can get the idea of any element when we see at that particular knowledge tablet or knowledge book or knowledge paper. We must get a short and sweet information about that element. So, main classification means recognition. Who is who? That is called classification. Let us see who tried first. First question, page number 16, and first question of the lesson is, why was it necessary to classify the elements? Why was it necessary to classify the elements? Today, there are 118 elements are known to the scientific world. Choose correct alternative. Fill in the blank will come from this sentence. However, around year 1800, so approximately 220 years back, only about 30 elements were known. More number of elements were discovered in the course of time. Initially, less numbers of elements were known to man. More and more information about the properties of elements was gathered. To ease the study of such a large number of elements and their compounds, scientists started studying the pattern, if any, in the vast information about them. Elements, their compounds, how they react, how they give the compounds. They started studying the pattern of their reacting nature or giving products. So that was the beginning of classification. In the initial classification, elements were classified into groups of metals and non-metals. This may give you idea of the previous studies in previous standard. Later on, another class of elements called metalloids was noticed. Metals, non-metals, and after that there was a new addition, metalloids. As the knowledge about elements and their properties went on increasing, different scientists started trying out different method of classification. Bracket complete. This is the question of why it was necessary to classify the elements. Next topic. First attempt made by the scientist called Dobereiner. Dobereiner. While studying the pattern, the atomic mass, that time atomic number was not knowing, people were not knowing the atomic number. So they were using atomic masses. Atomic masses, mass of one atom is called atomic masses. Atomic mass, they tried to, based on atomic mass, they tried to classify the elements. First attempt was made by Dobereiner. Dobereiner observed that there are some elements. If we arrange them in the group of three, in the increasing order of their atomic mass, in the increasing order of their atomic masses, if we arrange them in the group of three, see the sentence, if we arrange group of three elements in increasing order of their atomic masses. So atomic mass of lithium is 6.9, atomic mass of sodium is 23, and atomic mass of potassium symbol is K because it is kalium. In Latin it is called kalium. If we arrange in the increasing order of their atomic masses, we can see the atomic mass of the middle element. We can see the atomic mass of middle element is approximately the average of first and third. If we add the atomic masses of first and third and divide by 2, you will get approximately atomic mass of the middle one. So he called them triads. Group of three is called triads. Group of two is called couple, and group of three is called triads. He called them triads. Lithium, sodium, potassium, calcium, strontium, barium, chlorine, bromine, iodine. These three triads were given by Dobereiner. So he said something. The question is, write short note on Dobereiner's triads. Spelling must be correct. Dobereiner. In 1817, a German scientist, Dobereiner, John Wolfgang Dobereiner, suggested that properties of elements are related to their atomic masses. This was the fundamental sentence. He said, the way these elements are behaving, it is related to their atomic masses. He made a group of three elements, each having similar chemical properties, and called them triads. He arranged the three elements in the triads in an increasing order of atomic masses. In the increasing order of their atomic masses, and showed that the atomic mass of the middle element was approximately equal to the middle one. Showed that the atomic mass of the middle element was approximately equal to the mean of atomic masses of the other two elements. The atomic mass of the middle one is approximately equal to the average of these two calcium, barium gives 88.7, and actually we found it 87.6. Actually it's 87.6. 220 years back he was doing some studies. So approximately he said, approximately, here chlorine and iodine when they added, we get the average 81.2, and the actual atomic mass of bromine is 79.9. So he said, if we take average of first and last of atomic mass, add and divide by 2, you will get the middle, approximately atomic mass of the middle one. So next, however, all the known elements could not be classified into Dobbe-Reiner's triads. What you have to do in the answering, write the things what are in the textbook and give at least 2 examples of triad. That will give you the marks. Dobbe-Reiner arranged the metals, similar chemical properties, the elements having similar chemical properties, he arranged in the increasing order of their atomic masses, and he saw that the atomic mass of the middle one is the approximately average of first and third. After explaining this, you have to give at least 1 or 2 examples of triads so that it will be a complete answer. It will be a complete answer. The attempt was made by Dobbe-Reiner in 1817. After that, the English scientist, the scientist from England called Newland, tried to classify in 1866. In 1866, what he made, he arranged, instead of 3, he made a group of 8 elements in the increasing order of their atomic masses. Newland made group of 8 elements having in the increasing order of their atomic masses. He observed that the properties of the first one, the properties of the first element was similar to the 8th element. Newland arranged the elements in the increasing order of their atomic masses, and then he saw that the properties of the first element in the group, first exact, not same, but similar properties are given or shown by the 8th element. He concluded that the properties of elements are repeating after the gap of 8 elements. He concluded that the properties are repeating after the group of 8 element, 8th element. So what is the meaning of hydrogen is first. After that, the 8th one is fluorine. After hydrogen, he arranged in the increasing order of their atomic masses. He saw first and 8th element are showing similar properties. So after lithium, 1, 2, 3, 4, 5, 6, 7, 8. After lithium, sodium is giving similar properties. After sodium, you go on the eighth element, potassium is giving same properties. This was the attempt made by English scientist Newland. So instead of group of 3, he arranged broader group of 8 element, broader group, and he said the properties of first are similar to the eighth one. You start with sodium, it comes to potassium. From potassium, you go towards the eighth element, it is copper, cuprum. So, this was done by Newland. Let us see his work. Question is, like short note on Newland's octaves. Why they are called octave? It is like a music. It is like a music. We are in India, we are using sa, re, ga, ma, pa, dha, ni, sa. So eighth is again coming sa. Sa, re, ga, ma, pa, dha, ni, sa. In English, it is said to be, he showed by number 17, do, re, mi, fa, so, la and ti. After that it comes again do. The question is, write short note on Newland's octaves. The English scientist John Newland correlated the atomic masses of the elements to their properties in different way. In the year 1866, Newland arranged the elements known at that time in an increasing order of their atomic masses. It started with lightest element hydrogen and ended up with thorium. He found that every eighth element had properties similar to those of the first one. Just I explained you. Properties of first are similar to eighth element. For example, sodium is the eighth element from lithium and both have similar properties. Also, magnesium shows similar to beryllium and chlorine shows similarities with fluorine. Newland compared this similarity with the octaves in music. He called the similarity observed in the eighth and the first element as the law of octave. Law of octave. Newland compared the similarities with the octave in music. He called the similarity observed in the eighth and the first element as the law of octave. He simply said the properties of first and eighth are similar. This is called law of octave. To get good marks, you have to write this description plus one example or two example of octaves you must write there so that it will create